Last session of the day, and actually I'm really interested in this one because that's in a selfish way, because I'm a frequent traveller. I hate my plane being late. I hate my luggage being even later. And if there is a quicker, more efficient way to get me to my flight with the least possible hassle, the shortest possible delay, the least time wasted in the departure lounge, at an airport that is already operating close to capacity, then I want to know that. We have 4 speakers for this session. They are all absolutely at the top of their game. They handle things that, with luck, the rest of us simply don't notice at an airport because they're working in the background. So let's keep the presentation short, and then we've got some time for a bit of chat and a bit of debate. First up is Paul Adams. If I can ask you to come up first. Director of Global Strategic Marketing at Alcatel-Lucent. All yours.
Billy, but I was going to start with a joke, and the joke was, researching this, I thought I need to find a joke about an airport or a joke about runways, and the only joke about runways I could find, all of them ended with a punchline that was a derivation on the theme that the runway was very short but very wide, and which I didn't think was particularly funny, to be honest, and neither do you, clearly. But given that we were talking about passengers. And a subject of, when you talk about primary passengers, are quite important in the whole airline thing, I understand. I quite liked Ryanair's Chief Executive Michael O'Leary's point that he reputedly said recently, which was if he'd known that being nice to customers was so good for business, he would have done it years ago. And I actually used that line in a speech I wrote for my CEO a few weeks ago. Because in the telecoms industry, 80% of carriers think that they deliver outstanding customer service, but only 8% of their customers agree. So there's a bit of something from the telecoms industry there. But one of the things we talk about a lot in the industry is we talk about intelligence and network intelligence. And I liked this as a starting point because I think an airport should use the technology to kind of, to help its budget, to use its resources very effectively, to cope with passenger volumes and demands, and of course to help it make money. We all know that addressing passenger flow is a good investment. It helps the bottom line. It helps on-time departures and all that kind of stuff. But when that process starts including car parks and public transport, that process becomes a lot more complicated. It becomes complexity increases significantly. The intelligent airport that this quote's referring to, and I'm relatively sure that CETA have something of an agenda in it. But in this, that they're talking to, no one is stationary. Everybody is moving all the time. Everyone needs access to data. Everyone has access to applications from any location at any time. Why? Because they want to make the right decision, whether it's the decision to get through security, whether it's the decision to hit the gate on time. It's all about decision making. And the same's true for staff, for IT staff. They want to be able to get the right applications, the right resources, IT support resources, where they need them at the right time, through private cloud or whatever. And that means that the infrastructure underlying that needs to be robust, it needs to be secure, it needs to be something that everyone can connect to whenever they need to. And those connections will often be mobile, whether it's 4G or Wi-Fi or perhaps RFID, so near-field type technologies. And mobile is what's driving this. Now, we hear a lot about this. Even David Cameron's been going on about the Internet of Things. And once we've got these reports of these enormous number of connected devices and how it's going to change the nature of networks and all these kinds of things, it will change the approach of how networks are built. And that's because the Internet of Things, or IoT as it's known, as I'm sure you know, is all about connectivity. Without connectivity, you have nothing. Typically today, in the networks that we have, we don't have intelligent networks. We don't have ubiquitous connectivity, mainly because they've grown organically. They've grown over time, and on layers upon layers. It's like BT's network, for example, right? BT's network has grown organically since 1879, when the first public telephone exchange opened with 8 subscribers on it. So that was the starting point, and now look at where they are today. So is in BT's network, as in most enterprise networks, there are lots of individual layers of networks, one for phones, one for IT, one for that system over there, one for this system over there. And the challenge is, if you build networks on networks on networks, that breeds inefficiency. And inefficiency damages throughput. Doesn't matter whether it's a telephone network or a motorway. Inefficiency damages throughput. So what does Alcatel-Lucent do in this space? Well, we provide the underlying infrastructure. We provide the plumbing, if you like, that ensures that the applications that are needed get to the right places where they're needed at the right time, with the security that's required. In short, we provide the connectivity. And I would separate those into a few very separate areas. Firstly, collaboration, so the capability for networks to, different types of networks to combine and collaborate between them, so voice and data networks, the ability for individuals to combine, perhaps having being able to share a conference, share video data and that kind of thing, or maybe combination of telephony, so mobile telephony and desk-based telephony being the same thing. Second is prediction. So prediction is all about, big data analytics is a big step, right? But in big data, everyone talks about insight. And the answer is not about insight. Insight's a three-stage process. It's hindsight, insight, and foresight. And what we need to be doing, it's not something that we do, but what we need to be doing is taking the data points that we have available and predicting a likely outcome. Resilience. Nothing damages throughput faster than failure. It doesn't matter if it's a network, a telecoms network, or a phone network, or a motorway. Failure is the thing that damages throughput the most. And finally, security. Security is at the heart of this way of thinking, right? Whether it's from the encryption that you get from at the fiber optic layer at the very bottom of the kind of network, the physical connectivity, or whether it's the network-based security that you can deploy in the network that looks for cybersecurity threats based on their behaviors, not on the piece of malware itself. So there's all sorts of things you can do, but you need the security, because I'm sure there are lots of organizations out there, many organizations, that would love to tamper with an airport IT system, right? So what does it look like? I'm in telecoms, and we have to do pictures like this. So essentially, the points on the left, access points, is where people or machines access the network. Those are aggregated into kind of faster and faster lanes, similar to a motorway, if you like. And then in the center you have is DWDM, which is optics, an optical core, which is self-healing, resilient, encrypted, and so on. What Alcatel-Lucent makes is everything across here. That's what we do. In telecoms, we talk about carrier class. You're in telecoms world, you're about carrier class. And what that really means is high reliability. That's actually what it means. If you're selling to the City of London, banks, right, they care about reliability and latency. Yeah? Because in a banking environment, milliseconds can mean millions of pounds in delay, if it's a delay. I would argue, and they have very resilient, highly scalable, very fast networks. I would argue that an airport network should actually be a better architected network than a banking network. Why? Because bankers don't fly through the air at 300 miles an hour, do they? Right? Maybe we'd like them to, right? But the point is, I would argue that the network needs to be highly resilient. So a couple of examples for you. This first one is actually very similar to this discussion, because this network, this is all, the network for this German airport, was all based on Alcatel-Lucent equipment. I don't want to do an Alcatel-Lucent sales pitch, but it's based on Alcatel-Lucent equipment, and it's all about a step change in passenger numbers. And their realization to support that step change and all the data that's going to go flying across their network, that they needed a step change in their network architecture. This second one is a bit different, because what this Spanish airport decided to do is they decided to take the architecture that they had deployed and offer services to other businesses in the airport campus. Kind of like a mini BT, if you like. It's quite a good idea, isn't it? It's a way of, and the TCO on this was obviously vastly improved from a TCO of just deploying a network. And then finally, I wanted to just show you a few other examples of other ATCs where we are currently or have deployed networks. Just to show you that it's a general trend, right? There's a general trend moving towards carrier class, highly robust, connectivity-based networking in airports. That's all from me. Is that 10 minutes? Where do you want me to go here?
Come and take a seat here.